Assalamualaikum warahmatullahi wabarakatuh, and very good day to all of you. Welcome to UMC073, which is Fundamental Mathematics course. So now you are on topic 5, which is calculus. In this topic, you will learn a few subtopics, which are introduction to differentiation, differentiation of the polynomial function, differentiation of the composite function, differentiation by using product rule, differentiation by using quotient rule, the introduction to integration, the integration of definite and indefinite integrals, and also the properties of definite and indefinite integration. So, at the end of this topic, I expect all of you to understand the concept of differentiation, to understand on how to differentiate the polynomial function and also the composite function, to understand how to use product rule and quotient rule to do a differentiation of the function, to understand the concept of integration, to understand on how to integrate the definite and indefinite integrals, and also to understand the properties of definite and indefinite integrals. So let's start our topic 5, calculus. Okay, everyone, before we go to the introduction and the definition of differentiation process, let's see the concept of limits, because we will use limits to understand how to do a differentiation later. So what is the limit of a function? The limit of a function fx is an approximate value of fx as x approaches a point. So if we have one function fx, for example, here you have fx equal to 3x minus 2, we want to find what is the value of this function when the value of x approaches value 2. Okay, so it is not the value of fx at that point. It doesn't mean that when we are finding the value of limit at x approaching one point, it doesn't mean that that is the value of fx at x equal to 2. For example, in our case, we have fx equal to 3x minus 2. Okay, fx also is the value of y. When you have a two-axis graph, okay, you have here x and you have here y. Y, we also call it as a function of x. Okay, let's say we have one linear line on the graph, which is this linear line presented by the function 3x minus 2. So this one is called as a function of x. Means that if we want to find the value of y at a certain value of x, we need to substitute the value of x here. Okay, but when we are talking about a limit, okay, when we are talking about a limit, we are now want to find what is the limit for the function 3x minus 2 when the value of x approaching 2. Okay, so what is the value that we are finding here is, if you can see, the value of x start with 0 here. Okay, and then we can have the value of x equal to 1 and the value of x equal to 2. So when the value of x approaching 2, okay, when the value of x approaching 2, we want to find what is the value of a function fx. But it is not the exact value at x equal to 2. We just find the approaching value, okay, the closing value when x equal to 2. Okay, when x go close to 2, what is the value of your function fx here? Okay, so limit of a function fx is usually written as limit of the function fx when x approaching a. What we need to do is we just need to substitute the value of x here with what is the value of a that we want to find. So in our case, we want to find what is the value of limit for the function 3x minus 2 when the value of x is approaching 2. So how to find the limit of fx when x approaching 2? Okay, so we want to find the limit of a function fx, which is 3x minus 2, when x approaching 2, when the value of x approaching 2. So how to find the value of limit? The only way is to substitute the x here with whatever value that you want to find here. Okay, so now we want to find when x approaching 2. So we need to substitute the value of x equal to 2. So what we will have here is 3, x substitute with 2 minus 2. So 3 multiplied by 2, you will get 6. Okay, minus 2. So 6 minus 2 is equal to 4. So it means that when the value of x approaching 2, the value of 3x minus 2 is approaching 4. Okay, so this is called the limit of a function, because we want to use the concept of limit later when we want to see how the concept of first principle of differentiation. So what you need to know is, to find the limit of a function, you just need to substitute what is the value of x. Okay, the concept comes from the two-axis graph. Okay, when we have two-axis graph, we will have the value of x, and we also have the value of y, or we call this one as a function of x, is equal thing. So when you have a function on the graph, let's say the straight line, which is the equation is 3x minus 2. Okay, so we want to find the value of the function when the value of x approaching any value here. Let's say that just now we find when x approaching 2. So let's say we want to find when the value of x approaching 3. So what is the value of fx? How? By substituting the value of x in the function. If we want to find when x approaching 3, then we substitute the value of x here with 3. Okay, and we will find the limit of a function when x approaching any value. Okay, now we want to see the definition of the differentiation as an introduction to the differentiation process. So the differentiation of a function fx is actually a process of finding the slope or gradient of that function at a point. That one is actually the definition of the differentiation, where actually the process of differentiation is actually a process to find a gradient of a straight line, a gradient of a slope. Okay, so if you can remember previously, you might have learned on how to find the gradient of the straight line. Let's say we have two-axis graph, which is we have the x-axis here, okay, and we have the y-axis. So you have one straight line on your graph. Okay, you have 2 points, which is the first point here is the point x1, y1, and the second point here is the point x2, y2. Okay, where x1 is here, the first point of x, y1 is here, the first point of y, okay, and then x2 is here, the second point of x, and y2 is here, the second point of y. So how can you find the gradient of this straight line? Is by using the formula of gradient, where to find the gradient of straight line M, the formula will be y2 minus y1 divided by x2 minus x1. Okay, this is the formula of the gradient. So actually, the process of differentiation is based on this formula, where it is a process of finding the slope of the gradient of a function. So in the differentiation process, let's say we have the two-axis graph here. You can see the two-axis graph here. We have the x-axis and also the y-axis. And previously, I have told you that y-axis also can be represented by the fx, the function of f. Now, the function of x. So, we have two values of x. The first value of x is x. and the second value of x is x plus h. What is x plus h actually? So x plus h is the value of x here plus with some step here, which is h. Okay, for example, if you have the value of x here equal to 2, okay, and here you have 2 steps. Okay, so what is the value of your x plus h? It will be 2 plus with 2, which is 4. Okay, so we actually have 2 points of x here, where the first point of x is x. This one is our x1, and the second point of x is actually x plus h. This one is our x2. Okay, and the first point of our y will be fx. Okay, fx is equal to y, is the same things. Okay, where to find the value of y here, we need to substitute the value of x in the function f. Okay, that is the meaning of fx. For example, if you have your fx is equal to 3x minus 2. How to find the value here? If your x is equal to 2, you substitute the value, right? So now your fx is actually 3 times 2 minus 2 equal to 4. So your value of y is equal to 4. Okay, so actually the value of fx is the value of y. So if you have x plus h, means that your value of fx will be fx plus h. Because when you have the value of x, okay, when you have the value of x, the value of y is the function of your x. So it becomes fx. When your value of x is x plus h, your value of y will become the function of x plus h. That's why your second value of y here is fx plus h. It is actually the second value of your y. Or if I can label it, it will become here. This one is your x1. This one is your x2, this one is your y1, and this one is your y2. So previously I told you that the process of differentiation come from the formula of the gradient. This one, the same thing as the formula of the gradient of your function. Okay, so if you are using this formula, which is y2 minus y1, so now your y2 is equal to fx plus h. So if you write the formula here, you will have m equal to fx plus h, because your y2 now is fx plus h minus y1. So your y1 is fx divided by x2. Your x2 is x plus h minus x1. So your x1 is x. Okay, so if you can see here, x minus with x will be eliminated. So what left in your gradient formula here is fx plus h minus fx divided by h. Okay, it comes from the formula of gradient, and we will find the limit of this function when the value of h approaching 0. So this one is called as a first principle of differentiation, where the first principle of differentiation actually comes from the formula to find the slope of the function. Okay, where the formula to find the slope of the function come from the previous formula to find gradient that we learned before. Okay, so this one actually the first concept or the definition of the differentiation, where again I repeat, the process of differentiation actually the process of finding the slope or a gradient of a function. Okay, it's just that we applying the value, the limit here. Okay, where we want to find what is the value of y when the step here approaching 0. H is the step. H is the step between x1 and x2. So we want to find what is the value of y when x2 is closest to x1. The value of step approaching 0, no step between x1 and x2. So that one is the first principle of differentiation. Therefore, every time we have been asked to find the differentiation of certain function by using the first principle of differentiation, we need to remember that the first principle of differentiation is by using the formula where to find the limit of h approaching 0, fx plus h minus fx divided by h. Okay, so how to find the differentiation of a function by using first principle? So you need to know that it is two things that you need in this formula. The first thing is what is your fx plus h. The second thing is what is your fx, because we want to use these two values to put inside the formula. So now you already have your fx. This one is your fx. What left for us to do is to find what is our fx plus h. Alright class, so you can see here, if you have a value of x here, therefore inside the equation you will have a value of x. So if you want to find what is fx plus h, what you need to do is you just need to substitute all value of x in your equation with x plus h. So now we actually can find our x plus h by substituting this value of x with x plus h. So you will have x plus h to the power of 2 plus 2. Okay, so now you need to expand. X plus h to the power of 2 is actually x plus h multiplied by x plus h plus with 2. Okay, so x multiplied by x, you will get x squared. X multiplied by h, you will get x h positive. H multiplied by x, you will get hx, or xh is the same thing, so positive xh, and h multiplied by h, you will get h to the power of 2, and don't forget you have plus 2 at the back of the equation. So now class, we can see, okay, what we have here is x squared, okay, xh plus xh is 2xh plus h squared plus 2. So this is actually your fx plus h. So how you get your xx plus h? By substituting x that you have in your equation here with x plus h. So now you already have your fx to put inside the formula here. You already have your fx plus h to put inside the formula here. What is this formula? This is the first principle of differentiation. So now we can use this formula. Limit h approaching 0. So what is your fx plus h? You copy all your equation that you have here, which is x squared plus 2xh plus h squared plus 2 minus with your fx. So what is your fx? This one is your fx. So minus, you need to put the bracket x squared plus 2 divide by h. So just write divide by h. Alright, okay class, now we want to simplify this equation. So you have limit h approaching 0, you have your x squared, just write down x squared here. You have your 2xh from here, plus with h squared, plus with 2, okay, negative and positive, you will get negative x squared, negative and positive 2, you will get negative 2 divided by h. Alright, what you can do here is x square minus x square finish, eliminated. 2 minus 2, 0, also eliminated. So what you have left in your equation is just limit of h approaching 0 to xh plus h squared divided by h. Okay, next, before we can substitute the value of h equal to 0 to find the limit of this function, you can factorize h because in this equation you have h, in this equation also you have h. Okay, so what you can do is you factorize out your h. Okay, so you factorize out your h. Therefore, this term only left with 2x plus with this term only left with 1h because you factorize out. Okay, and we have h in denominator. So what we can do is we can cancel both h in the numerator and denominator. So you only left with limit h approaching 0 2x plus h. So previously, when we learn or when we see the concept of limit, how to find the limit of a function? We just need to substitute the value of h equal to 0 inside our equation. So now we substitute the value of h equal to 0. We will have 2x plus 0 equal to 2x. So this one is actually the differentiation of a function fx x squared plus 2 here. Means that if you are doing the process of differentiation of this function, what you will get is this one, 2x, by using the process or the formula of first principle of differentiation. Later we will learn on how to use the formula to differentiate, but now we are using the first principle of differentiation for differentiation process. Okay, let's see this example where we have been asked to differentiate a function of 2x plus 4x to the power of 2 by using first principle. Again, remember the first principle of differentiation can be found by using the formula of limit h approaching 0, fx plus h minus with fx divided by h. Okay, so what we need is the value of fx plus h, the value of our function fx, to use this formula. So we already have fx here. What you need to find is what is the value of fx plus h. So class, again, if you have fx, to find the value of fx plus h, you just need to substitute the value of x here with x plus h. This one also you need to substitute with x plus h. So what we have is 2x plus h plus with 4x plus h to the power of 2. Okay, after substituting, let's simplify our equation. So now to simplify, you open the bracket. 2 multiplied by x, you will have 2x. 2 multiplied by h, you will have positive 2h. Okay, plus with 4, and you need to expand this first. X plus h to the power of 2, you will get x squared plus 2hx plus h squared. This one is similar to the previous one. And then you open the bracket, expand again. So you have your 2x here plus with 2h here and here, positive 4 multiplied by x square, you will have 4x square. Positive 4 multiplied by 2hx, you will get positive 8hx. Positive 4 multiplied by h square, you will get positive 4h square. Okay, so this is your fx plus h. This one is your fx plus h. Now we can use the formula of first principle of differentiation. So let's use the formula. We have to find the limit of h approaching 0. Fx plus h, you need to copy all the function here. So you have 2x plus 2h plus with 4x squared plus with 8hx plus with 4h squared minus with your fx. So your fx is this one, minus with 2x plus 4x squared. Don't forget to put your bracket. Okay, divide by h. So this one is the formula for first principle of differentiation. Now we want to expand our equation here. Okay, so we have limit h approaching 0. In front here, you just need to copy 2x plus 2h plus 4x square plus 8hx plus with 4h square. Negative and positive 2x, you will get negative 2x. Negative and positive 4x square, you will get negative 4x square here, and you have h in your denominator. So let's see what we can cancel out in our equation here. You have 2x minus 2x here, finish, equal to 0. You also have 4x squared minus 4x squared here, also equal to 0. So it can be eliminated. So what you left in your equation is just that limit h approaching 0, 2h plus 8hx plus 4h squared, okay, divide by h. So if you can see, all term that you have in your equation here have h. This one also have h. This one also have h. So what we can do is we can factor out h. Okay, so what you have is limit h approaching 0, you factor out 1h. So what left for your term here? Only 2, because you already factor out your h. Plus, this one you factor out h, it left only 8x. Okay, plus, this one you factor out 1h, so it left only 1h here. Okay, and don't forget that you have your h in the denominator. So you have h in numerator, you have h in denominator. What you can do is you can cancel out both h. Okay, so you only left with you only left with limit of h approaching 0 for the function 2 plus 8x plus 4h. So how to find the limit? Just now we learned to find the limit of a function, it is just to substitute the value of h equal to 0 inside your h in the equation. So what you will have here is 2 plus with 8x plus with 4 multiplied by 0, because the value of h now is equal to 0. So you have here 2 plus 8x plus 0. 4 multiplied by 0 is 0. So you have 2 plus 8x. So what is actually 2 plus 8x? 2 plus 8x here, class, is actually the differentiation of a function fx equal to 2x plus 4x squared. It means that whenever you are differentiating this function 2x plus 4x squared, you will get it is equal to 2 plus 8x. This one we call as the differentiation. So if we have the symbol of fx here, okay, the differentiation of fx can be denoted by f prime x. Means that if you have fx equal to 2x plus 4x squared, by process of differentiation, it will become f prime. The symbol is f prime. What is the value after differentiation? 2 plus 8x. We already find by using the first principle. But if we are using the symbol y in front of this equation, for example, you have y equal to 2x plus 4x squared. When we are differentiating this function with respect to x, the symbol will be dy dx. Okay, it means that the differentiation of value of a function y with respect to x. And what is the value of the differentiation? What is the value of differentiation? It will be 2 plus 8x, the one that we find by using the first principle. So this one is the notation that we use for our function and its derivative.